Okay, so in this video we're going to have a look at problem solving using Venn diagrams. Now there's a few different types of questions on this, some where we can use a double Venn diagram and some where we need to use a triple Venn diagram like the one that you can see on the screen. So this is the type of question we're going to build up to, but before we do that we need to have a look at the double Venn diagram questions and how to solve these problems when they're involved. So with that being said, let's get started. Okay, so in this video we're obviously going to look at solving problems with Venn diagrams. Now you obviously need to be aware of how to use Venn diagrams as well when we are looking at inputting numbers from a given set of lists. And I'll link that in the description for you to check out as well, but in this one we're going to have a look at these more problem solving style based questions. So the one that you can see on the screen, we're going to have a little read through. It says 50 students were asked if they have a cat or a dog. 22 have a cat, 18 have a dog, 8 have both a cat and a dog. Use this information to complete the Venn diagram. Now sometimes you'll be given a Venn diagram, sometimes you'll have to draw it for yourself. For the purpose of these videos I've put them all in, but just be aware that you could have to draw them. So obviously if we have a Venn diagram we need to label it up to start with. Now this question mentions cat first, so I'm going to put the right as the other one and the left one as the one that's mentioned first. So I'm going to put cat here and I'm going to put dog over there. Again, it doesn't matter what order you put it in, just make sure that it's clearly labelled. So looking at this question, it first says to us that 22 have a cat. Now the problem with the Venn diagram is we can't just put 22 in this cat section because there are some people that also have a dog, so some of them are going to have to go in there. So don't just put the first number in straight away, instead let's read through the entire question and see what information we have been given that could be put straight in. So it then says that 18 have a dog. Again, we can't put that straight in. If it did want us to put it straight in, it would say only before the word dog. So it would say 18 people have only a dog. But there we go, we can't put that in. So moving on to the next bit, it says 8 have both a cat and a dog. So that bit of information can go in because we know that 8 that have a cat and a dog would have to go into the centre. So straight away in the middle, we can put that 8 have both. It doesn't tell us how many have neither, so that is the unknown piece of information we're going to have to work out. Now we can move back to that first line as it says that 22 have a cat. Now you can already see that part of those 22 over here, we've got 8 that will have a cat and a dog, but those 8 people are included in the 22 people that have a cat. So to work out how many people have only a cat, we would have to take away the 8 in the middle from the 22. So do your working out to the side, I would write 22 take away 8, and that is going to give us a total of 14 that have a cat. And now you can check because these two numbers should add up to 22. So 14 and 8, do they add up to 22? The answer is yes, so we've got that correct. We can then move on to the 18 that have a dog. Now of course we've still got the 8 in the middle, so we would take away the 8 in the middle that have both away from the 18, and that leaves us with a total of 10. So 10 people have only a dog. And now we've got quite a lot of information there, but we need to figure out what goes on the outside. Now if we add all of those up, so 14 plus the 8 plus the 10, that adds up to 32. So we have 32 people. Yeah, it does add up to 32, yep. We've got 32 people, so we need to figure out what goes on the outside. So at the moment we've got 32. To make that up to 50, we would have an additional 18 people that would go on the outside that have neither a cat nor a dog. Okay, so that's one type of question that you can have where we've been told what goes in the middle in the crossover section, in the intersection. So let's have a look at one that's slightly different. Okay, so this question here is slightly harder, and this is the one that you're going to practice after we've gone over it. So you'll see why this is harder as we read through it, so let's go and read through it. It says 50 students were asked if they had a brother or a sister. It then says 24 have a brother, 28 have a sister, and then it says 6 has neither a brother or a sister, but it doesn't tell us how much has both. So the first bit of information that we can put in here is this 6 that have neither, because that is going to go onto the outside of the Venn diagram. Of course we need to make sure we've labelled this as well, so the brother is mentioned first, so I'll put brother and sister, and now we're ready to start filling in those other bits of information. Now the issue here is we don't know how many's in the middle. but we know that 24 in total is going to go into the brother section and 28 is going to go into the sister section. And we can do this using a little bit of algebra and just thinking about what these pieces would have to be. Now, if we don't know what's in the middle, let's call that x. And again, you could use any letter here, but I'm going to use the letter x. And then, therefore, to work out the brother, we would have to do the total, which we know is 24, and we would have to take away that number in the middle. That's how we would work it out. So let's call this section 24 minus x. And I'll tell you what, I'm going to put that next to it over here as well. So 24, take away the number in the middle. We would have to do the same for the sister section. We would do 28, take away the number in the middle. And again, let's actually write the correct number there. That would be 28, take away x. So again, let's label that to the side, 28 minus x. We can now figure it out using a little bit of algebra here in solving an equation. If we add these three pieces together in the middle, we know what they're going to have to add up to. Because if there are 6 on the outside and 50 are asked in total, they have to add up to 44. And again, we could write down that working out just over here because there are 50 people in total. Take away the 6 on the outside means the total inside our Venn diagram has to add up to 44. So if we add those three pieces together, we have 24 minus x plus x, which is going to cancel that x out, plus the 28 minus x. Now if we add those together, we've got, and we can start with the numbers, 24 and 28, which adds up to 52. So we have 52, and then the x and the minus x cancel each other out, and we have the minus x at the end. So those three pieces in the middle combine to make 52 minus x. And we know that the 52 take away x has to add up to 44. So we can work that out. So 52 take away x has to equal 44. So what is that number? Well, let's just think about this logically. X will have to equal whatever the difference is between 52 and 44, and that is equal to 8. So now we've solved it, and we have that x is equal to 8, we can just apply that to the numbers in our Venn diagram. So that was the big bit of working out here, and that was figuring out that x was equal to 8. So now we can put them in. So 8 would go in the middle, 28 take away 8 on the right there would be 20, and 24 take away 8 would be 16. And there we go, we've got our three numbers into the Venn diagram. Now, as with all of these questions, you should just quickly add those numbers up just to make sure that they add up to 50. 16 add the 6 is 22, add the 8 is 30, and add the 20 is adding it up to 50. So have a little read through that. If that was obviously relatively quick, so have a little read through, have a think about how I made that equation, and then we're going to have a look at a question for you to have a go at. The question that you're going to have a go at is going to be very similar to this one. So let's have a look at that now. Okay, so here's your question looking at one of those where you've got to put x in the middle. So pause the video here, try and make your equation, try and see if you can figure out what number goes in the middle, and see if you can finish off this Venn diagram. Okay, so let's start putting some numbers in. So the first thing that you can put in here is the fact that 8 have neither. So we can put 8 onto the outside. We then have to form our equation, so we can say that x is in the middle. We need to label it up, so brother and sister. We can say that the brother is going to be 18 minus x, as it says that 18 have a brother. We know that the sister is going to be 20 minus x, as 20 have a sister. If we add those all together, you end up with 38 minus x, and we need to find what that has to be equal to. So it says in the question that 40 students were asked, and we have 8 on the outside. So if we do 40, take away 8, what's left over to go in our Venn diagram is 32 people. So 38 take away x has got to be equal to 32. And that means that x has got to be equal to 6. So the number in the centre of our Venn diagram is going to be the number 6. So we can put 6 in the middle. And then we've got 18 take away 6 on the left, which is a total of 12. And we've got 20 take away 6 on the right, which is a total of 14. And again, just adding those four numbers together, 8 and 12 makes 20, add the 6 is 26, add the 14, adds us up to 40. So we've completed that Venn diagram. Okay, so that was looking at a Venn diagram where we had two circles. Now we're going to have a look when there are three things involved. So let's have a look at that now. Okay, so the level of difficulty on this question is going to jump up quite a lot. There are three circles that we have to take into account, and this question has an actual probability question at the end. And the probability question at the end, look, if we read the very last line, says that Chris selects at random 2 of the 50 people, work out the probability that they both like tea. So we've got quite a lot to work out here. So let's go through the information. It says that Chris asked 50 people which drink they liked. And it says tea, coffee and milk. So let's label those straight away. I'm going to go in a clockwise direction starting with the top left. So tea, coffee and milk. It then says lots of bits of information. We've got all 50 people like at least one of the drinks, which tells us straight away there's nobody on the outside. So actually we could put a number in straight away. We could put 0 straight in the outside. It then says 19 people like all 3 drinks. Now that can go in straight away as well. So if 19 like all 3, then we know that 19 goes straight in the middle. And what I would encourage you to do is to tick them off as you go. So we'll tick those off and we'll get rid of this highlighter. So let's have a look at the next bit. 16 people like tea and coffee but do not like milk. So 16 like tea and coffee but not milk. Now the fact that it says but not milk gives us a very specific place where it has to go. So the crossover with tea and coffee is this little section just here. And those people in that section, they like tea and coffee, but they don't like milk. So we can put that number straight in. We would have to be very careful though if it didn't say but not like milk, because there are some people that like tea and coffee and like milk, and of course they're in the centre just here. So because it tells us that these 16 people don't like milk, then those 16 people can go straight in the crossover between tea and coffee. And again, we can tick that off. On to the next bit of information. It says 21 people like coffee and milk. Now here is where we do have to be careful, because let's first find the coffee and milk section, which is just here. But some of those people we already know like coffee and milk. We've got 19 in the middle that like coffee, milk, but also like tea. Now this one here doesn't say but they don't like tea. So part of those people are already in the Venn diagram. So if there's 21 people that like coffee and milk, and we've already got 19 in the middle, that would be an additional 2 people. Now we have in total 21 people that like coffee and milk. We've got 19 in the middle there, and the additional 2 that like coffee and milk on the outside part. So that part is done, but that is one that you need to be careful of. So being very careful with that one, and that is also going to relate to this next one. So this next one here is very similar. It says 24 people like tea and milk. Well, the crossover for tea and milk is just here. And we already know that we've got some people that already like tea and milk. We've got the 19 in the centre, just like that last piece of information. So it doesn't say we've got 24 people that like tea and milk but don't like coffee, like in that earlier bit of information. This time 24 people like tea and milk. So because we've already got 19 in there, that is going to be an additional 5 people, because 19 and 5 adds up to a total of 24. And now we've got a total of 24 people that like tea and milk. So again, we can tick that off, and you can see how careful you've got to be here with the words. So on to our next bit of information. It says 40 people like coffee. So 40 people like coffee, but we've already got quite a lot of people in the coffee section. We've got over here the 2, the 19 and the 16. So if we add all of those together, that adds up to a total of 37. 16 plus 19 is 35, plus the 2 is 37. So for the additional people that like coffee, it's going to go from the total there of 37 up to what it tells us, which is 40. So that is going to be an additional 3 people. And again, if you add up those 4 numbers in the coffee circle, they now add up to 40. So that one's completed. We've got one more bit of information here, and that's quite a nice one. It says that one person likes only milk. So in the only milk section, we can put one person. And that was a nice bit of information to finish, but of course we've got our final section to fill in. We've got to fill in how many people like only tea. It's the only number that's missing now, and that's what goes into here. So if we're going to figure that one out, we've got to figure out how many we've already got in total. So of course we've got the 0 on the outside. An easy way to add this up, we already know that there's 40 people in the coffee circle, and then we just have the extra 5 and the extra 1, so that adds up to 46. Of course, it has to add up to 50, so to get from 46 to 50, that would be an additional 4 people that must only like tea. So that's all the information filled in. You can see how careful I had to be with all of the information there, particularly with the language of the question. So when you are reading through these, I would definitely advise you to highlight them or tick them off as you go, and just to be very careful of the words. Now this question does have an additional part to it. It says that Chris selects at random 2 of the 50 people, work out the probability that they both like tea. Now if we're going to select 2 people here, you're probably already aware of what we might have to do thinking about conditional probability. Or if we are looking at tree diagrams, those dependent events, and when we take one person out, we know what happens to the denominator of a probability. And again, I'll link that video in the description so you can have another look at working out those multiple probability outcomes. So if we're going to select a person that likes tea, and again we've got to be very careful with the words here because it doesn't say that they both only like tea. If it said that they both only liked tea, then we would be looking at those 4 people that only like tea, but we have lots of people here that like tea. We've got the 4 people here that only like tea, we've got the 16 that like only tea and coffee, we've got the 19 that like all 3, and we've got the 5 people that only like tea and milk. So there's a lot of people here that like tea, and if we add them all together, let's have a think. 4 plus 16 is 20, plus the 19 gets us to 39, and plus the 5 gets us to 44. So the probability of selecting one person that likes tea is going to be 44 out of 50. And we are going to select 2 people. So if we select the first person and they like tea, then the next probability is going to be 43 people that like tea, and it's only going to be out of 49. So both the numerator and denominator would decrease as we've taken out one of those people that like tea and also taken out one of the 50 people. So hopefully you already remember what to do with these types of probabilities. Again, the video for dependent events of probability trees would be very helpful here, but we multiply them together. Now this is a calculator based question, so you would have a calculator to work this out, but of course 44 times 43 you could do to the side. It does come out as a very large number here, but that comes out as 1892. So there are 1,892 different ways of that happening out of a total of 50 times 49, and 50 times 49 is 2,450. So it's a very large probability there. It's not very nice. It doesn't look very nice, but that is our final answer. So when it comes to this, of course, you could be asked different questions. You could have just been asked, what's the probability of one person that likes tea? In which case you would have just said 44 out of 50. It could have also rephrased the question and it could have said, work out the probability that they only like tea. And if it said the probability that they only like tea, let's just have a look at that. If it said 2 people that only like tea, it would have been a lot nicer as our fraction, because there are only 4 people that only like tea out of 50, and then once we take one of those out, there would only be 3 people, and again that would be out of 49. So it just means that our top number would have been 12, 4 times 3, and our bottom number would have still been 2,450. So that is obviously a different question. That would be if they said, work out the probability that they both only like tea. And of course that could change in case they said only like coffee or one of the other elements within the Venn diagram. So that's how you're going to go about answering these. Obviously this is quite a high level question. There's a lot of information for you to read, but let's have a look at a question for you to have a go at. Okay, so here's your question. So you're going to want to read this very, very carefully, go through all of the information super carefully, filling it all in, and then have a go at working out that probability question. So pause the video there, we'll go over the answers in just a sec. Okay, so it says here 50 people were asked if they speak French or German, French or Spanish. So let's first label it up. We've got German, we've got French, and we've got Spanish. It then says 31 people speak French. Now, of course, that's no good to us. We can't put that in straight away, so we'll skip past that for the moment. It says here 2 people speak French, German and Spanish. So that is all 3. So we can put the 2 straight in the middle. So we can tick that off and we can move on to our next piece of information. It then says 4 people speak French and Spanish but not German. The fact that it says but not German means we can put that straight in. So 4 people speak French and Spanish, which is in the crossover of French and Spanish, but not German. So that's 4 people going just there. Of course, if you've labelled up your letters in slightly different places, then you're just going to have to amend this to obviously suit the way that you've drawn it. It says 7 people speak German and Spanish. So for German and Spanish, it says 7 people speak that, but it doesn't say that they don't speak French. So that's going to also include the 2 people that are already in there. So that is only going to be 5 that we put into that section. Now in total we have 7 people that speak German and Spanish. So we can tick that off. I'm happy with that. It says 8 do not speak any of the languages at all. So this time we're going to have 8 on the outside. And that's that bit of information done. It then says 10 people who speak German speak at least one of the other languages. So we've got 10 people that speak German, but there's no people that only speak German. So in terms of that information, that gives us two numbers. It tells us that there are 0 people that speak only German, but it tells us that there are 10 people that speak German in total. Now if we look in our Venn diagram, we've got 5 and 2, and at the moment that adds up to 7. So that's going to be an additional 3 people here that must speak French as well as German. So that's that bit of information, and that gave us 2 of the numbers. We now need to go all the way back to the start because there was another piece of information that we missed out. So it says here 31 people speak French. Now at the moment, if you look, we have 3 people in the French section. We've got 3, 2 and 4. Sorry, more than 3 people, but 3 numbers. So 3 and 2 is 5 plus the 4 adds up to 9. So to make that get up to 31, we're going to have to go from 9 to 31, which is an additional 22 people. So that's 22 people that speak only French, because that now means that our French circle adds up to 31. And we're going to keep that there and remember that, because that's going to help us to add them all up. So all of these numbers, remember, have to add up to 50 because there are 50 people in total, and we have 31 in the French section. We've got an additional 5 there that are in the German and Spanish, so that adds up to 36 in total, and then we have 8 on the outside. So 36 adding the 8 gets us to 44, which means there must be an additional 6 people that speak only Spanish. Right, so adding those all up to check, they do add up to 50. So we know that we've got our total correct. Now we can go to our probability question. 2 of the 50 people are chosen at random. Work out the probability they both only speak Spanish. So that word only is very important. That's what we talked about on the previous question. So the fact that they speak only Spanish means that the main number, or the only number we're looking at here, is these 6 people that only speak Spanish. So in total, we would have 6 out of 50 for our first pick. Then on the next pick, what we're going to multiply it by for that second person, it's going to be 5 people, but now it's going to be out of 49. So 6 out of 50 on the first pick. If we remove one of those people, there would only be 5 out of 49. So to work this out, we can do the numerators multiplied together. 6 times 5 is equal to 30. And on the denominator there, again, we've got 50 times 49, which comes out as 2,450. And there we go, there's our final answer, 30 people out of 2,450 different possibilities. So that is how we go about problem solving with Venn diagrams when we had 2 circles and when we had 3. I hope that was useful and helpful. Don't forget to check out the other videos on Venn diagrams and obviously the video on dependent tree diagrams for just recapping this multiplication and the calculation there that we use to work out that probability. So I hope you found that useful. If you did, please like, please comment, please subscribe, and I'll see you for the next video.